grade 10 learners! I got another lesson for you that still involves geometric sequences. This time, you will learn how to insert terms in between two numbers of a geometric sequence and how to get the sum of geometric sequences. I am Teacher Sarah, your facilitator in exploring geometric means and geometric series. But before we get into the lesson, let's go over the objectives of this video. After watching it, you should be able to determine the geometric means between two terms and find the sum of the nth term of a given finite or infinite geometric sequence. So, let's make a start on studying geometric means. These are terms between two numbers in a geometric sequence. For example, in the geometric sequence 1, 6, 36, and 216. 6 is in between 1 and 36. Therefore, it is the geometric mean of the two numbers. How about the geometric means between 1 and 216? Great job! If you identified 6 and 36 as the geometric means of 1 and 216. To solve for the geometric mean between two numbers, use this formula, where GM stands for the geometric mean, A sub 1 is the first term, and A sub n is the last term. Take note that you use this formula only if you are finding the geometric mean between two numbers. Consider the following examples.
Example 1 tells us to find the geometric mean between 9 and 16. The two numbers involved here are 9 and 16, and they are considered as the first term and last term respectively. They are the given values in the problem, and we are asked to solve for their geometric mean. Let's have the formula. Geometric mean is equal to positive negative square root of A sub 1 times A sub n. We can see here that all we have to do is to multiply the two given terms and then extract the square root of the product. This formula was derived using the square root property. That's why we have the positive negative symbols. It means that we are to consider the positive and negative roots of the equation. In this case, we are considering the positive and negative geometric mean of the two numbers. Substituting the given values in the formula, we have geometric mean is equal to the positive negative square root of the product of 9 and 16, which is 144. Extracting the square root of 144, we have 12. Therefore, the geometric mean is equal to positive negative 12. It means that the geometric mean between 9 and 16 can either be positive 12 or negative 12. So if we're going to write the sequence, we can have it as 9, 12, 16 or 9, negative 12, 16. For example 2, we are going to find the geometric mean of 2/3 and 24. Let us write the formula, then substitute the given values. So we have geometric mean is equal to the positive negative square root of 2/3 times 24. These are our first term and last term. We can simplify this radicand by canceling the common factor of 3 and 24. Dividing 24 by 3 gives us 8. When we multiply 8 by 2, we get 16. So we can now extract the square root of 16 that will give us the geometric mean that is equal to positive or negative 4.
What about if we are to insert two or more geometric means between two terms? Like the geometric sequence that appears like this. What are we going to do? It means that we are going to insert three geometric means to form a geometric sequence. And we can only do that by solving first for the common ratio. We will be using this formula where R is the common ratio, A sub n is the last term, A sub 1 is the first term, and n is the number of terms. Let's take a look at the following illustrative examples.
Let us insert three geometric means between 2 and 32. Inserting three geometric means between 2 and 32 indicates that there will be 5 terms in the geometric sequence, where 2 is the first term or A sub 1, and 32 is the last term or A sub n. For the number of terms, there will be 5, since we are to insert 3 terms. 1, 2, 3, plus the 2 given terms, making it 5. To be able to find the geometric means to be inserted, we need to solve first for the common ratio, so we will know the constant number that we are going to multiply to every term to get the sequence. We will use the given formula R equals n minus 1 root of A sub n divided by A sub 1. Let us substitute the known values, so we have R equals 5 minus 1 root of 32 divided by 2. So if you're going to simplify the equation, 5 minus 1 is 4, and 32 divided by 2 is 16. So we have the resulting equation, R equals 4th root of 16. Extracting the 4th root of 16 gives us the value of R, which is 2. Now we know the common ratio, so we can start multiplying it to 2 to fill in the blanks and complete the geometric sequence. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. We can see here that we inserted 3 geometric means between 2 and 32, which are 4, 8, and 16.
Finding the sum of the first n terms of a geometric sequence can also be an interesting activity. The sum of a geometric sequence is called geometric series. There are ways to find the sum of the first n terms without actually adding all the terms. In this lesson, we will learn finite and infinite geometric series. We can get the sum of a geometric sequence that contains a finite number of terms. We can use this formula. S sub n equals A sub 1 times the quantity of 1 minus r raised to n all over 1 minus r. As long as r must not be equal to 1. In the given formula, S sub n is the sum of the geometric sequence, A sub 1 is the first term, n is the number of terms, and r is the constant ratio. Take note that this first formula is used when the number of terms, the first term, and the common ratio are known. Let us go over these examples.
In example 1, we are going to find the sum of the first 6 terms of the geometric sequence 36, 18, 9, and so on. Before we solve this problem, Let us recall that a finite sequence has a finite number of terms, meaning it has a last term. So in this problem, we are asked to find the sum of the first 6 terms of the sequence, meaning we are going to add the first term, which is 36, to the second term, which is 18, to the third term, which is 9, up to the 6th term. So, the last term is the 6th term, making it a finite sequence. Let us now identify the given values. The first term is 36. The common ratio is 1/2. We got that by dividing 18 by 36, and the number of terms is 6. We will solve for the sum of the first 6 terms represented by S sub 6. Let us now substitute the given values in the formula. S sub n equals a sub 1 times the quantity of 1 minus r raised to n divided by 1 minus r. We have here the sum of the first 6 terms is equal to 36 times the quantity of 1 minus 1/2 raised to 6 divided by 1 minus 1/2. We need to simplify first the exponential expression in the enclosed quantity. So 1/2 raised to 6 is 1 over 64. We are now ready to do the other operations in the equation, resulting to S sub 6 equals 36 times the quantity of 63 over 64 divided by 1/2. We can cancel out the common factor of 36 and 64, which is 4. So 36 by 4 is 9, and 64 by 4 is 16. Then we can multiply the numerator, so 9 by 63 is 567 over 16 divided by 1/2. When we divide this fraction, we need to get the reciprocal of our denominator, which is 1/2. Its reciprocal is 2 over 1. Then multiply it to the numerator, 567 over 16. Cancel out common factor of 16 and 2. So we have here now 567 over 8. The sum of the first 6 terms of the given geometric sequence. Let us try to solve example 2. Find the sum of the first 7 terms of a geometric sequence 3, 6, 12, 24, and so on. Let us identify the given values. So a sub 1 is 3. The common ratio is solved by dividing 6 by 3, so it gave us 2. And the number of terms is 7 because we are looking for the sum of the first 7 terms. Write the equation and substitute the given values. So we have the sum of the first 7 terms is equal to 3 times the quantity of 1 minus 2 raised to 7 divided by 1 minus 2. Simplify 2 raised to 7. Multiply 2 by itself 7 times and it will give us 128. So, combine like terms inside the parentheses. We have 1 minus 128 will give us negative 127. Multiply it to 3 and divide it to negative 1 will give us the sum of the 7 terms that is equal to 381.
We also have another formula that can be used in finding the sum of the terms of a geometric sequence whose last term is given and the number of terms is not given. We have here S sub n equals a sub 1 minus a sub n times r all over 1 minus r, provided that r must not be equal to 1. Remember that this form requires the first term, the last term, and the common ratio, but does not require the number of terms. Let's dive in with the given examples.
Let us find the sum of a geometric sequence whose first term is 128, the last term is 2, and the common ratio is 1/2. We can see here in the problem that the first term, the last term, and the common ratio are readily identified. So, identifying the given values, a sub 1 is 128, a sub n is equal to 2, and r is equal to 1/2. What are we looking for? We are going to solve for the sum of the geometric sequence being described in the problem. Replacing the variables in this formula with the given values, we have now the geometric series that is equal to 128 minus 2 times 1/2 divided by 1 minus 1/2. First, we can simplify this equation by canceling out 2 and then get the difference between the terms in the denominator so that we have the geometric series that is equal to 127 divided by 1/2. We can simplify this by getting the reciprocal of the denominator, which is 2 over 1, and multiply it to the numerator, that is 127. So the sum of the geometric sequence, whose first term is 128, whose last term is 2, and having a common ratio of 1/2, is 254.
Getting the sum of geometric sequence with infinite number of terms is also possible. We can solve for the sum of infinite geometric series using the formula sum to infinity is equal to a sub 1 all over 1 minus r, provided that the absolute value of r must be less than 1. In the formula, S sub infinity stands for the sum of the infinite geometric sequence. A sub 1 equals first term and r is the common ratio. Let's examine the following problems.
Let us consider example 1. What is the sum to infinity of 24, 4, 2/3, 1 over 9, and so on? Let us remember that an infinite geometric sequence contains an infinite number of terms, which means the list of numbers continues without end. So how do we get the sum of a continuous sequence? First is to check if the given sequence has a sum or if there is none. How are we going to do it? Check if the absolute value of r is less than 1. This is the given condition in the formula, so we will be able to use it. Let us determine the common ratio of this sequence then. Divide the second term by the first term, which is 4 divided by 24, that gives 1 over 6. Next is to get the absolute value of 1 over 6, which is equal to 1 over 6. When we say absolute value, this is the non-negative value of the given number without regard to its sign. So the absolute value of any real number is always positive. In this case, the geometric sequence has a sum. Since the absolute value of r, which is 1 over 6, is less than 1, it satisfied the given condition. We then proceed in identifying the other given values in the problem. So, a sub 1 is equal to 24, and we are going to solve for the sum to infinity of the given sequence. Write the formula Sum to infinity is equal to a sub 1 all over 1 minus r. Substituting the given values, we have sum to infinity is equal to 24 all over 1 minus 1 over 6. Let us simplify the denominator, subtract 1 over 6 from 1, and the equation will be sum to infinity is equal to 24 all over 5 over 6. Divide this expression, it will be 24 times 6 over 5. So we have the sum to infinity that is equal to 144 over 5. How about this second example? Find the sum to infinity of the geometric sequence 2, -6, 18, -54, and so on. Again, we need to satisfy the given condition that the absolute value of r must be less than 1. So, get the common ratio of the sequence. -6 divided by 2 gives us -3. Next is to get the absolute value of -3, which is 3. Take note that 3 is more than 1. It did not satisfy the given condition. So, this geometric sequence has no sum, since the absolute value of -3 is 3, which is more than 1. It means to say that the sum of the terms of this geometric sequence does not exist.
Alright! I hope that you enjoyed this week's lesson. Have fun in learning, stay safe, and God bless.